so here for question number 2 on the quiz, we have all the exact same initial information. All right, with the same initial information, we know how much work is done by friction as the stuffed monkey is moved 6 meters. All right, couple different approaches. One is we can recognize that if the thing is moving at a constant velocity, we know it is, right? Here, constant velocity, that means we know that the net work done over the 6 meters has to be equal to 0. All right? How does that work out? That can only be true if the net force acting along that plane, right? The net force acting in this direction must be 0, right? So net force in this direction here has got to be equal to 0. All right? If we do a free body diagram and we get force here, we get friction here, we get normal force here, which we're going to have to use in a second, right? Once we start talking about friction, we need to include the vertical direction because normal force is a part of that. And then we have mg acting downward. Notice I made mg a little bit bigger than normal force. Talk about that in a minute. Okay? So that means if we're talking about in this horizontal direction, I'll make it blue for contrast here, that that what we're looking at in terms of net force in that direction, all right, has got to be equal to 0. So that means that the component in this direction, and I'll use a big fat arrow here, this component right here, which we can call fx, what is fx equal to? That's just f cosine, oh, that's f, I should have made it t, right? Sorry about that. We decided to call that, here's our tension, all right, so tx is equal to t cosine theta, okay? So we look at the work, we're not looking at the work, we're just looking at making the net force in the x direction equal to 0 to ensure that the velocity is constant. So based on that, we know that tx plus negative friction has got to be equal to 0. Why negative? Because it's a force, so it does have direction, so the negative indicates that the force is in the backwards direction, this way. All right? So that means that rearranging here, we just get tx is equal to force. Since we know that tx is t cosine theta is equal to friction. All right? And that means that friction is equal to, well, so what we could do is just say the work done by friction has got to be equal to the force of friction. All right? Here we'll do it as a dot product again, so we can show it more formally. And that's just going to be friction times distance times the cosine of the angle between friction and the displacement, right? And what is that angle going to be? Excellent. All right, so the work done by friction is going to be equal to, and of course, that's cosine of 180 is equal to what? -1. Good. All right, so we're going to put that in here. We're just going to say negative FD, but we know that friction is equal to what? From up here is t cosine theta, right? T cosine theta. T. Bless you. All right, so we got t cosine theta t times distance negative. Work done by friction is equal to, no surprise, it turns out to be, all right, we get negative 15 newtons times the cosine of, this is theta t, right? Not our 180. This is back to our other one, which is 20 degrees times our 6 meters, 6.0 meters. Didn't write that correctly. That's the same math we just did before, isn't it? All right, and what does that turn out to be? Negative 85 newtons. Okay, so this is the work done by kinetic friction. Oh, Mr. Culbertson. All right, Jules, thank you for helping me, everybody. All right, so doesn't that make sense? Well, let's think about it. How much work is the normal force doing, and why? How much work is the normal force doing? Thank you. Why is it doing 0? It's perpendicular to the displacement. How much work is the weight vector doing? 0, again, because it's perpendicular. So all of the work is getting done by, the only thing that does either positive or negative work, or work that has any magnitude at all, is that done by friction and that done by the tension force. So basically, since delta V is equal to 0, right? Delta V is equal to 0, that means the change in kinetic energy is equal to 0. That means the net work done is equal to, guess what? 0. since we figured out that the work done by tension is equal to 85, not newtons, joules, that means that the work done by friction has to be equal to negative 85 joules because the net work is equal to 0. And those are the only two things that do net work that's non-zero. Okay? Does that make sense? All right.